Good morning. I, Mrs. V.A. Yavle, Assistant Professor, Department of Electrical Engineering, AISSMS IOIT, would be discussing today some basic concepts of digital control system. Let's first see the points of discussion for today. We would be seeing basic introduction to digital control system. Before understanding the digital control system, there are various types of signals that are to be understood. Then we'll see the block diagram of DCS and advantages of DCS. A digital control system model can be viewed from different perspectives, including control algorithm, computer program, conversion between analog and digital domains, system performance, etc. One of the most important aspects is the sampling process level. Modern control systems require control of numerous loops at the same time, for example, pressure, position, velocity, and tension. Before understanding the digital control system, first let's try to understand various types of signals. A continuous time signal, as you can see in the diagram, is defined over a continuous range of time. The amplitude of the signal may vary over a finite number of distinct values. The process of representing a variable by a set of distinct values is called quantization, and the resulting distinct values are called quantized values. An analog signal is a signal defined over a continuous range of time whose amplitude can assume a continuous range of values. Then we have a discrete signal. A discrete signal is a time series consisting of a sequence of quantities. Unlike a continuous time signal, a discrete time signal is not a function of continuous argument. However, it may have been obtained by sampling from a continuous signal. So this is how a discrete sampled signal usually looks like. Then we would see a digital signal. A digital signal is a signal that is being used to represent data as a sequence of discrete values. At any given time, it can only take on one of a finite number of values. This contrasts with an analog signal which represents continuous values. At any given time, it represents a real number within a continuous range of values. In digital signal, the physical quantity representing the information may be a variable electric current or voltage, the intensity, phase, or polarization of an optical or other electromagnetic field, acoustic pressure, the magnetization of a magnetic storage media, etc. Digital signals are used in all digital electronics, notably computing equipment and data transmission. With now that we have understood an analog signal and a digital signal, this is how they both basically look like. Signal fundamentals, analog, discrete and digital signals. So as we have discussed earlier, let's try to understand them through these different waveforms. So an analog signal is an electrical waveform with the continuously varying possible amplitudes of a quantity, may be voltage or current. It is uniquely defined for all t, which means that at a particular time instant, I'll have a particular unique value. A discrete signal is one that exists at discrete time. It is characterized by a sequence of numbers at each time kt, where k is an integer and capital T is a fixed time interval. It's sometimes referred to as pulse amplitude modulated signal because the amplitude of a pulse stream is modulated, means varied by the amplitude of an analog signal. So a discrete signal would look like this. A digital signal is one that has finite set of positive amplitudes and has a value at a particular instant of time. Simple graphs for a continuous time analog signal will look something like this. For a continuous time quantized signal, where we had seen quantization earlier, will look like this. A sampled data signal would be something of this nature, and a digital signal is of something of this nature, will have a specific value. Now we can see clearly what an analog signal means, and how a discrete signal for the same analog signal would behave or would look like. Let us now see, after understanding the different types of signals, let's see the block diagram of a digital control system. The block diagram of a digital control system has a sample and hold circuit with a to D converter. It has a digital computer, a D to A converter, a hold circuit, actuator, a plant or the process, and a transducer. So this is the basic block diagram of a digital control system. Now let's see how all these blocks they function and what is the importance of each of the block and the function of each of the block. The sample and hold circuit term used for sample and hold circuit is nothing but the amplifier. It describes a circuit that receives an analog input signal and holds this signal at a constant value for a specified period of time. A sample and hold circuit is generally used along with an A to D converter. An analog to digital converter, which is nothing but an encoder, is a device that converts an analog signal to a digital one, usually a numerically coded signal. The conversion of an analog signal into the corresponding digital signal, that is a binary number, is an approximation, and this approximation process is called as quantization. The digital to analog converter, it's also known as a decoder, is a device that converts a digital signal into an analog signal. The plant or the process is any physical object which is to be controlled. Maybe examples are a furnace, a chemical reactor, and a set of machine parts functioning together to perform a particular operation, such as a servo system or a spacecraft. A transducer is a device which will convert an input signal into an output signal of another form, such as a device that converts a pressure signal into a voltage output. So, this explains the various blocks of the digital control system. Let us see why a digital systems are important or what are the advantages of digital system. The first and foremost importance of digital system is the ease of programmability. The digital systems can be used for different applications by simply changing the program without additional changes in the hardware. Reduction in cost of the hardware. The cost of hardware gets reduced by use of digital components, and this has been possible due to advantages in IC technology. With ICs, the number of components that can be placed in a given area of silicon are increased, which helps in cost reduction. High-speed digital processing of data ensures high speed of operation, which is possible due to advances in digital signal processing. Digital systems are highly reliable, and one of the reasons for that is the use of error correction codes. The design of a digital system is comparatively easy, which require use of Boolean algebra and other digital techniques is easier compared to analog designing. The result can be reproduced easily since the output of digital systems, unlike analog system, is independent of temperature, noise, humidity, and other characteristics of components. The reproducibility of results is higher in digital systems than in analog systems. So with this, I would like to end the discussion. Hope you all have understood basically the different types of signals, the digital control system, the various blocks involved in the digital control system, and the advantages and usefulness of digital control system. Thank you. Thank you.